Hello everybody and welcome back to the channel. Okay, in this lesson we are going to determine what minimum height to apply from natural ground level, okay, so that's our topo solid, to the floor level inside the dwelling. Okay, now for the purposes of this project we're going to be using Melbourne, Australia as the location, and that's going to make sense very soon. Okay. So the NCC, remember that's the National Construction Code for Australia only. Okay, it is very specific about minimum heights of floor levels above natural ground levels, especially for concrete slabs. Okay, because concrete slabs sit lower to the ground than flooring systems on stumps or piles. Okay, so again, be aware that the NCC does only apply to Australia. Your region will have different requirements, but the science behind it will be similar. Okay, so physics doesn't change, hydraulic engineering doesn't change. It just really, the local conditions of your area will determine how you design. And again, please don't forget to like, subscribe, and share this channel so I can keep helping others. Okay, so it's not really a Revit lesson today. It really is just about taking the next step so that we can actually build something. Okay, so in my notes here, I've got some information. Okay, so this image here, now this all of this is taken from the NCC. Okay, so this image here is an example of what we are talking about. Okay, so this part here, it's a concrete slab, and they've displayed what's called a stiffened raft. Okay, which is a slab there with deepened edge beams. Okay, to compensate for a timber frame and likely brickwork. Okay, so what we're after is this level here, the finished floor level above the finished external surface. So this would be the natural ground level when the job is completed and landscaping is done. Okay, so we need to figure out what this distance has to be. Okay, this is what the lesson's all about. Okay, so in the NCC, it gives us three minimum options. Okay, minimum heights above that external finished surface. Okay, we have 100 millimeters minimum. Okay, that is if your area is in a low rainfall intensity area or sandy, well drained areas. Okay, so that's option number one. Option number two is 50 millimeters above impermeable areas that slope away from the building. Okay, so instead of not having natural ground here, this could be a paved or a concrete footpath or a driveway. Okay, in that case, you would need 50 millimeters. 150 millimeter clearance in any other case. Now the question is, how do we know if we are in a low rainfall intensity area? Okay, so first things first, in the NCC, we have to go to find a definition. Okay, and the definition within the NCC for a low rainfall intensity area is an area with a 5-minute rainfall intensity of an annual exceedance probability of 5%. I'm not going to worry about how we interpret that too clearly, but not more than 125 millimeters per hour. So I'm basically, in 5 minutes, there should be no more, it's a 5% chance of not receiving more than 125 millimeters, which is an incredible amount of water, okay, in 5 minutes. Okay, So these rain intensity figures, okay, we get from table 7.4.3D in the ABC housing provisions, which are part of the NCC. Okay. Now remember, I said before that we're going to assume that our project is in Melbourne. So this is an excerpt, this is just a piece of this table here. I've gone to the state, which is Victoria, the locality, Melbourne, and that annual exceedance probability there, we see there is 132 millimeters. Okay, so 132 millimeters is greater than 125 millimeters. Okay, so when we go back to our slab on ground, we are allowed 100 millimeters if we are in a low intensity area, okay, which we're not, okay, because Melbourne exceeds the 125. Okay, so what this means is that for this project, okay, the minimum height for our slab, it's the finished floor level, the minimum height above the natural ground level, okay, the finished external surface, is going to be 150 millimeters. That is the number that we need to play with. Okay, so got a couple of minutes left in this video. Okay, so when we go into 3D, okay, what we're going to have to do is find the highest point of where the building envelope is going to sit on the topo surface or a natural ground, and jack and go up 150 millimeters. Okay, so let's go, actually we have the time to do this in our video. Okay, so I'm going to go to level 0, okay, and pretty sure that this area here, yes, 5500, this is our high point, this corner here. Okay, so if I go and have a look at this section here, okay, this is the high point. Now the other thing as well is we're not going to be cutting, we're just going to build our house on top of the land. We're not going to try and beat nature, we're just going to build on top of what we've got. Okay, so at this point here, we need to be 150 millimeters above ground level because that is the high point. That is going to mean that we're going to have a deeper fall at other areas, and that is perfectly okay. We will review that as we go. Okay, so just a quick summary. Okay, we need to find out what this minimum distance is, okay, for a slab on ground. Okay, we have determined that we have we do not have a low rainfall intensity area because Melbourne's annual exceedance probability is 132. It needs to be less than 125. Okay, which means we need to have the slab on ground clear above the external finished surface by at least 150 millimeters. That is the rule, and that is what we call deemed to satisfy, i.e. if we design exactly as the NCC tells us to, then we will comply with the NCC. Right, this wraps up this lesson today. In the next one, we're actually going to set the levels and start seeing what that does to our design. Okay, but in the meantime, we will see you later.